A Falcon 9 second stage has crashed into the moon, spurring plenty of negative headlines, but is it actually a big deal? NASA's got an update on the Artemis moon program, Blue Origin narrows down the cause of New Glen's massive explosion, we're getting ready for next week's total solar eclipse, and much more is coming up this week in Spaceflight. We're starting with Artemis, as NASA has just released a whole series of updates, beginning with the robotic lunar landers and the initial phase of the agency's future moon base. Of the many companies taking part in NASA's Commercial Lunar Payload Services contract, 4 currently have missions assigned: Blue Origin, Firefly, Intuitive Machines, and Voyager. Incidentally, the 4th company on that list used to be Robotic, but it was recently acquired by Voyager Technologies, so it's now officially Voyager. Blue Origin is preparing its first Blue Moon Mark I lander, called Endurance, for a mission now officially targeted for the first quarter of 2027. Earlier this year, the lander completed a series of environmental tests at NASA's Johnson Space Center before returning to Blue Origin's facilities at the Kennedy Space Center. There, it underwent acoustic and vibration testing, along with tests to verify its response during separation from New Glenn. More recently, it completed communications testing using both NASA's Tracking and Data Relay satellite system and the Deep Space Network. Blue Origin also carried out an engine fit check with the BE-7 engine that will power the mission, which we covered just a few weeks ago. With those milestones now complete, the next major test will involve loading cryogenic propellants into the lander to verify that its propellant storage and pressurization systems perform as expected ahead of launch. That testing will take place at a dedicated test stand to the north of Launch Complex 36, near the future Launch Complex 36B launch pad, which we'll be talking about later in the episode. You might be wondering what happens if testing is completed before New Glenn is ready to return to flight. Well, during this update, Blue Origin's John Koulouris explains that the company plans to place the lander into a quiescent state until New Glenn is ready to carry it to the moon. Meanwhile, Firefly is pressing ahead with the company's second Blue Ghost mission, which will become the first American lunar lander to attempt a landing on the far side of the moon. According to the latest update, the vehicle's primary structure has now been completed, with teams currently outfitting the lander ahead of pre-launch testing and final integration. Intuitive Machines is also moving closer to the launch of its next Nova C lander, Trinity. Trent Martin, the company's senior vice president of space systems, explained that the next major milestone will take place next month, when the lander's main engine will be installed and fired on the company's test stand to verify that the propulsion systems are ready for flight. Afterwards, the lander will return to its integration facility, where it will receive its exterior panels and payload hardware. As for Voyager, its Griffin 1 lander is currently at NASA's Jet Propulsion Laboratory undergoing environmental testing to confirm it can withstand the harsh conditions of space. That campaign should wrap up in the coming weeks, before the lander heads to the Kennedy Space Center for integration with the Falcon Heavy rocket that will launch it later this year. Alongside the robotic landers, NASA also announced a partnership with Northrop Grumman to fly 3 technology demonstration payloads to the lunar surface. These demonstrations will make use of technologies originally developed for the Habitation and Logistics Outpost, or HALO module, of the now cancelled Gateway Station. The demonstrations will focus on key technologies, including systems capable of surviving the lunar night, power and data distribution, avionics, and much more. The lessons learned from these missions can then be applied to future lunar surface habitats and other moon-based hardware. But well before NASA gets to a fully fledged moon base, it has to launch the next Artemis mission, and preparations are gathering pace as we speak. Just this week, the mission reached one of its major milestones with the mating of the Orion crew module and its European service module. There is still plenty of work to do, as this image released by NASA clearly shows, but this is where things start to get really exciting. With the 2 modules now joined together, engineers can complete the electrical, data, and fluid connections between them before powering up the fully integrated spacecraft for functional testing. They can also carry out further integrated testing along with the final outfitting of both modules ahead of flight. On the rocket side, NASA has also made progress manufacturing the spacer that will be used in place of the Space Launch System upper stage, the Interim Cryogenic Propulsion Stage, or ICPS. For Artemis III, NASA does not need this upper stage, as it is instead reserving it for Artemis IV. However, Orion cannot be mounted directly onto the core stage because of the resulting height and interface differences, so this spacer will take the place of what would normally be the ICPS liquid hydrogen tank. The spacer has now been welded together at NASA's Marshall Spaceflight Center and will next receive its forward and aft attachment rings. NASA has also announced that it will use the structural test articles for the Launch Vehicle Stage Adapter and the Orion Stage Adapter, the two other major components that connect Orion to the Space Launch System core stage. These structural test articles were built and tested several years ago, before production of the flight hardware. Using them for Artemis III will allow NASA to preserve the remaining flight articles for the Artemis IV mission instead. It will be interesting to see how many modifications these long-stored test articles require to meet flight specifications. The good news is that Artemis III will have more than enough Space Launch System performance to place Orion into low Earth orbit, so even if extra reinforcements or additional hardware are needed, there is plenty of performance margin available. Meanwhile, the other two major elements of the rocket, the core stage and the solid rocket boosters, are being processed in parallel ahead of stacking and testing later this year. NASA says processing of the solid rocket booster segments has been accelerated by almost 4 months in comparison to Artemis II. In addition, the 4 RS-25 engines for the core stage, which arrived last month, are now being prepared for installation inside the vehicle assembly building. To help speed up Artemis III and the missions that follow, NASA is also reusing components from the Artemis II Orion spacecraft on later vehicles. This is not entirely new. NASA has already reused some avionics from Artemis I's Orion on the Artemis II spacecraft, and component reuse has always been part of the long-term plan for future missions. What has changed this time is that NASA is now also reusing components from the Artemis II Orion on the Artemis III spacecraft that were originally intended to be newly manufactured. Taking this approach allows engineers to install certain pieces of hardware on Artemis III's Orion much earlier, while making newly built components available sooner for the Artemis IV spacecraft. The agency is also looking at reusing more than 250 components from the Artemis II Orion on the spacecraft for Artemis IV and Artemis V, helping to shorten production timelines and reduce costs. NASA also released several images of the Orion crew module and European service module for Artemis IV as they continue preparations for flight. If NASA wants to achieve a faster launch cadence with the Space Launch System, then the Orion spacecraft flying on those rockets will also need to be completed on a similarly efficient schedule. NASA also recently released images and videos showing construction of the Artemis IV core stage at the Michoud Assembly Facility in New Orleans, Louisiana. While the footage was only just released, some of the work shown actually took place a few weeks ago, something we have unfortunately become quite accustomed to these days. With both of the core stage's main tanks now complete, they have begun progressing through the series of proof tests and cleaning processes required before the famous spray-on foam insulation, SOFI, is applied. For the liquid oxygen tank, it recently completed hydrostatic proof testing, which, as the name suggests, involves filling the tank with pressurized water to verify that it is leak-free and able to withstand the pressures it will experience during flight. The liquid hydrogen tank, meanwhile, has also completed its own testing campaign and will soon begin cleaning operations. It'll be interesting to compare where the fourth core stage stands at the end of these processes compared with the third, and determine exactly how much faster production has become this time around. Of course, that will have to wait for a future episode, and I'm pretty sure there's a subscribe button to make sure you don't miss it. From the big orange rocket to the big blue rocket, Blue Origin is getting closer to fully completing its investigation into what caused New Glen's explosion about 2.5 months ago. This week, CEO Dave Limp provided an update on the investigation, stating that the anomaly originated at the main oxygen valve of one of the BE-4 engines on the booster. The wording seems to suggest that data from the rocket led them to suspect this was what happened, and that an inspection of the rocket's debris then confirmed it. Limp did not elaborate on exactly what kind of valve issue led to the explosion, but he did say that the company has been conducting tests at both the component level and on complete engines so they can better understand that failure mode. What's interesting is that this has led them to only need small modifications that can be retrofitted into existing engines, something that could probably save some valuable manufacturing time and money. There's still some investigation left, as he says they're still working through the fault tree analysis, but it does seem like Blue is on a good path towards understanding and fixing the issue and getting back to launch, of course, once the pad is ready. While pad repairs continue at Launch Complex 36A, Blue is preparing for New Glen's future launch pad at Launch Complex 36B, just a few hundred meters north. This pad is planned for the much larger and more powerful New Glenn 9x4, about 120 meters tall with a planned capacity of 70 metric tons to low Earth orbit. Among the work needed for a new pad, it's not all just construction, but also paperwork. Part of this paperwork involves applying for an analysis that ensures any tall structures, permanent or temporary, don't endanger existing aerial routes or impact any nearby airports. This week, the company applied for a new one of these analyses related to a large mobile crane up to 228 meters tall that will be used for construction at the site. Blue also applied separately for the mobile crane that will be used at the neighbouring LC-36A for New Glenn operations, so they're likely getting rather close to installing it now. What's interesting is the fact that they also updated two existing analyses, one for the LC-36B umbilical tower and another for the LC-36B lightning protection tower. The company had applied for these analyses back in April, with the launch tower planned to stand up to 152 meters tall and the lightning tower planned to stand up to 182 meters tall. In this week's update, the numbers have changed quite a bit. According to the updated documentation, the umbilical tower would have been shortened to 83.8 meters tall, while the lightning tower would grow taller to 218 meters tall. It's quite odd that they've changed it this way, given that New Glenn 9x4 is going to be a gigantic rocket. Standing at nearly 120 meters tall means the rocket will be almost 40 meters above the top of the umbilical tower. An umbilical tower will have to connect to the second stage and possibly to the rocket's fairing as well, to provide environmental control for the payloads. Even assuming that such a connection to the fairing will be located right at the top of the tower and will be attached right at the bottom of the fairing, it would mean the fairing is nearly 40 meters tall, which wouldn't really make much sense. So, needless to say, something's off here, and the change in the documentation could imply a change in the rocket's design, so don't be surprised if we feature that in an upcoming episode. Relativity Space is quickly clearing major milestones for its reusable Terran R. Over the last week, the company has announced that the rocket's first stage has now completed structural qualification testing. The dedicated test article was put through more than 400 pressure cycles to validate its long-term durability and was pushed well beyond its normal operating limits while pressurized. Together, those tests prove the tank can handle everything from routine ground operations to the extreme stresses of flight. On top of this, Relativity has been conducting testing of Terran R's second stage at Stennis. There, the vehicle went through a series of cryogenic proof tests as well as pressurization tests that validate the design ahead of the next major step, a hot fire test. For that, the second stage will come off the stand. It will then be fitted with its Aeon-V engine and then reinstalled on the stand for the hot fire. At the same time, the company is preparing for a similar test with the first stage. Right now, Relativity is integrating the first Aeon R engines on a Stage 1 thrust structure at the company's facility in Long Beach. This thrust structure should join the rest of the Stage 1 structure and go to Stennis for that hot fire test before shipping to the pad for launch. This would put the rocket on a good path towards flight before too long, and, if successful, could even put it ahead of fellow competitors such as Rocket Lab's Neutron. In the case of that rocket, structural qualification of the first stage hasn't been fully completed yet, and the second stage hasn't been fired up either. By the way, quickly on Neutron while we're on the topic, NSF's Wallops correspondent Micah Bizarko spotted Neutron's Hungry Hippo fairing fitted with its aerodynamic fins outside Rocket Lab's assembly and integration complex. The structures seem to have been fitted onto a scaffold, so perhaps this could be to further outfit its interior. We'll definitely be keeping an eye on it. In Florida, United Launch Alliance has rolled its Vulcan rocket out of the pad at Slick 41 for testing. This Vulcan will carry the first low Earth orbit or LEO optimized version of the Centaur upper stage, built specifically for Amazon's LEO broadband satellites. And to be clear, the stage is named for LEO, the orbit, not LEO, the Amazon brand. So confusing. The Centaur LEO is about 1.8 meters shorter and carries roughly a third less propellant than the standard Centaur 5. That weight saving means more satellites can be carried on each launch. Having left the Vehicle Integration Facility Amazon, or VIF-A, the vehicle will spend about a week at the pad before returning to the building. Both the Centaur stage and the second Vulcan launch platform, or VLP-A, were thermally conditioned for cryogenic propellants before partial propellant loading into the upper stage only. With that complete, the final step was a full propellant loading test. This wet dress rehearsal runs through the entire countdown without actually launching, making sure everything is ready once the rocket gets the green light. Exactly when that green light will come, however, remains unclear. Vulcan has been grounded since February after experiencing its second solid rocket booster issue in just 4 flights, with a 1 in 6 SRB failure rate. In both cases, the core stage and Centaur compensated and still delivered their payload successfully into orbit. However, until that investigation is complete, Vulcan will remain grounded. This will be the rocket's first mission for Amazon's LEO constellation, and for now, ULA is doing everything it can to be ready the moment Vulcan is cleared for launch. NASA and SpaceX have now confirmed a launch date for the next crew headed to the International Space Station, and it's sooner than many expected. You may remember that Crew 13 was first announced at the beginning of May. Mission Commander Jessica Watkins will be joined by pilot Luke Delaney and 2 mission specialists, Canadian Space Agency astronaut Joshua Kutrick and Roscosmos cosmonaut Sergei Tetyatnikov. The latter 3 are all making their first spaceflight and will become the 296th, 7th and 8th people to visit the International Space Station as it rapidly approaches the milestone of 300 visitors. Watkins, however, is a veteran astronaut who completed her first spaceflight in 2022 as a mission specialist on Crew 4. This mission will make Jessica the first NASA astronaut to fly aboard Dragon twice. The crew will get their first real hands-on experience with the spacecraft starting on Friday the 7th of August, the day this episode airs. The test drive, as it's known, is a full dress rehearsal in their launch suits, including seat rotations, leak checks, communications checks, and even the chance to become familiar with the sounds Dragon makes in flight, all before they ever leave the ground. The mission is now scheduled to launch no earlier than the 12th of September. Previously, however, it had been expected to launch around November, so why has the launch been brought forward? Well, back in May, budget pressures had pushed crew missions beyond their usual 6-month cadence, as NASA's Dana Weigel explained.
So we made a shift to this 8 to 9 month kind of mission space, and then congressionally we ended up healthier. And so we're going back. What you're seeing is we're going back to our original plan. It is certainly our goal to give as many people the experience of flying as we can. It's going to serve us well, both for space station, but also as we look forward to the rest of our Artemis missions. And so we have pulled back the flight, and we are going back to about a 6 to 7 month spacing between all the missions.
Crew Dragon Grace will be flying for the second time, having made its debut last June on the Axiom 4 mission. Its serial number, C213, isn't the only reference to the number 13 on this mission. If the launch takes place on the first attempt, docking with the International Space Station would fall on the 13th of September. It's the first United States crewed mission to carry the number 13 since Apollo 13, and the mission patch even includes a nod to the legacy of that mission with its golden dragon and sweeping tail. Falcon 9 booster B1013, no, I'm just kidding, that booster's long gone. It's B1101, which will be making its 3rd flight. It launched the Crew 12 mission on its maiden flight and has since flown a batch of Starlinks. The launch will take place from Space Launch Complex 40 in Florida, where SpaceX is also replacing the mine-resistant ambush-protected vehicles, or MRAPs. These rescue vehicles are being swapped for Tesla Cybertrucks, which NASA says will allow crews to clear the blast danger area more quickly in the unlikely event of an emergency. This will be SpaceX's 53rd Dragon mission to the International Space Station and its 18th human spaceflight mission, but as Commander Watkins noted, the 4 people who sit inside Dragon represent a huge team of people behind such a mission.
We are the tip of this spear, the kind of the head of the iceberg, the visible part of an incredible team of people that make spaceflight happen. The amount of people that it takes to make it happen and do so seamlessly that it makes it look easy every time, that is such an incredible effort to represent and to be a part of.
Last week we covered some news about Starliner following Boeing's investor update, with the company suggesting that good progress was being made, although without going into much detail. This week, however, we learnt a little bit more about when NASA actually expects Starliner to return to flight. Dana Weigel, manager of NASA's Low Earth Orbit program, explained during this week's Crew 13 news conference how the agency is working to get Starliner back into orbit.
Teams are really working hard on Starliner. We'd like to get that vehicle back to flight. They've made a handful of hardware modifications, so it's really important for us to fly it as soon as it's ready so we can take a look at the system performance after those modifications have been made. So teams will look at the amount of technical work in front of us, the amount of scope, and all of the other dynamic operations that I mentioned that are ongoing on board Space Station to find the right time to fly that mission.
To address the overheating issues encountered on previous flights, Boeing has made modifications to the service module's propulsion system to direct heat away from the thrusters, including adding extra insulation around the thrusters themselves. These changes have been verified through ground testing at White Sands in New Mexico, but there is still more work to do. So is the real delay simply finding room for Starliner in the already busy International Space Station schedule?
It's a little bit of both. On the technical side, Boeing has done a great job making thermal modifications to the spacecraft. So when you make that type of modification, then you got to go back and kind of look at the integrated system and say, okay, how do I expect it to perform? with those modifications. So that's some of the work that's still being closed out. Separately, we have a pretty busy launch schedule. You know, we only have 2 docking ports, and we have a lot of other constraints on board, like we have beta cutouts when we can't do dockings. And so we've got to line up that body of technical work we need to complete with openings that we have on station. So that's something that we'll continue to look at as we get better resolution on the overall schedule to finish the technical work.
Even so, NASA is not ruling out a Starliner return to flight later this year. That mission will be uncrewed, but the packed International Space Station schedule could still accommodate it, as Dana explained.
There's still opportunities to launch in 26. We're going to make sure that we've laid in all the right technical work and that we use that to drive the schedule. But in terms of a space station flight plan and windows where I've got an open docking port, I've still got capability to fly Starliner in this year.
A crewed Starliner flight could then follow a successful uncrewed mission. Richard Jones, Deputy Director of the Commercial Crew Office within the Low Earth Orbit program, noted that although crew assignments are generally made around a year before launch, astronauts are already closely following Starliner's progress.
In terms of being ready for a Starliner mission, we're making a lot of progress in that area, understanding the anomalies that have been in place, and we're just making a lot of really good progress there. So we do have a lot of astronauts following every step of the way, right? They are following every single decision, assessment that are being done in that area. And so whenever that time comes for a crewed assignment, NASA will be ready to tell the public about who it is and why.
With encouraging updates now coming from both Boeing and NASA, let's hope we see Starliner return to the skies once again in the near future. Now let's take a look at some other stories from across space, starting in interstellar space. Nearly 50 years after their launch, NASA is still finding new ways to keep the Voyager probes operating. The twin probes launched back in 1977 and remain the only spacecraft ever to operate beyond the heliosphere. This vast protective bubble of charged particles and magnetic fields separates our solar system from interstellar space. The probes are powered by radioisotope thermoelectric generators, or RTGs, which convert the heat produced by decaying plutonium into electricity. The catch is that this power source is finite, with each probe losing around 4 watts of electrical power every year. After nearly half a century, that power margin has become incredibly slim. Engineers at NASA's Jet Propulsion Laboratory in California have carried out an ingenious procedure on Voyager 2 that they nicknamed the Big Bang. The team simultaneously switched off a number of non-essential powered systems while swapping in lower power alternatives, all while keeping the spacecraft warm enough to continue operating. The name might sound rather dramatic for what was actually a very careful and precisely coordinated power-saving exercise, but NASA plans to carry out the same procedure on Voyager 1 in the coming months. As a result, Voyager 2 should now be able to keep its 3 remaining science instruments operating for at least another year. That is down from the original 10 instruments, with 7 having been switched off over the decades to squeeze just a little more life out of the mission. Even so, that's not too bad for a pair of spacecraft whose original planned mission lasted just 4 years. And while NASA extends the life of its most distant probes, unfortunately the same cannot be said for satellite operator Hughes Satellite Systems, the company behind HughesNet Broadband, which has filed for bankruptcy after losing more than half of its customer base over the past 6 years. The company filed for Chapter 11 protection this week after being unable to repay $1.5 billion in bonds that matured on the 1st of August. The company's restructuring chief placed the blame squarely on the shift from satellites in geostationary orbit to low Earth orbit constellations, specifically naming Starlink and Amazon Leo as the main competitors. But let's be real, we all know where their business has really gone. Starlink has exploded in popularity since it started offering its service in 2020, and thanks to the fact that those satellites orbit 100 times closer to the ground than GEO, it takes much less time to deliver a message. The speed of light is literally the bottleneck here, and as a result, HughesNet's subscriber base has fallen to around 640,000 customers, down from more than 1.5 million in mid-2020. The newest satellite in Hughes' fleet, Jupiter 3, launched in 2023 aboard a SpaceX Falcon Heavy. At around 9,200 kilograms, it was the heaviest commercial communications satellite ever launched. It represented a huge and costly investment into the traditional one satellite does it all approach, launched by the very company whose own satellite constellation is now outcompeting it. Parent company EchoStar has not itself filed for bankruptcy, although 2 of its subsidiaries also entered Chapter 11 proceedings in July. Hughes says its services will continue throughout the restructuring process as the company shifts its focus towards enterprise and defense contracts, where it has a backlog worth around $1.5 billion. It's time for your weekly space traffic report from Next Spaceflight, and this week had more launch activity than last week, with 6 launches. SpaceX carried out 3 Falcon 9 launches, 2 of them being Starlink missions, putting an additional 48 Starlink satellites into orbit. The third Falcon 9 launch of the week carried 3 Bluebird satellites for AST Space Mobile, which is aiming to deliver direct-to-phone connectivity through its Bluebird constellation. 2 of the 6 launches this week occurred from China, one of them carrying a batch of Huawei internet satellites and another carrying a pair of commercial Earth observation satellites. To end the week, Rocket Lab finally launched the mission The Grain Goddess Provides, carrying a synthetic aperture radar Earth observation satellite for the Japanese company iQPS. This mission had originally attempted to launch all the way back on the 1st of July, but Electron suffered an abort right at engine ignition, prompting the rescheduling. On the International Space Station, NASA astronauts Jessica Meir and Anil Menon conducted a 6.5-hour spacewalk on the exterior of the station. The main goal of the event was to prepare the 3B power channel of the orbiting outpost for the installation of a new rollout solar array later this year. This is the first of 3 spacewalks scheduled for this month, with the other 2 expected to take place next week and near the end of the month respectively. This upcoming spacewalk next week will focus on replacing an aging space-to-ground antenna used for communications on the ISS. Of course, the big space traffic headlines this week were not about the ISS, but about the Moon, as this past Tuesday a roughly 4-ton Falcon 9 second stage impacted the Moon. But is it really that big of a deal? Well, the Moon is constantly bombarded by meteors of all sizes, and impacts from objects the size of this second stage tend to occur naturally once every 6 days or so. These impacts are so common that even astronauts on the Artemis II mission saw flashes from impacts quite a few times during the roughly 1-hour eclipse behind the Moon. Of course, that's because there's still dust and rocks spread out all over the solar system from its creation. It's a natural impact. So what about artificial ones? Those are far less frequent, but they still happen. Humanity began doing this in the early days of the space race, with both the Soviet Union and the United States crashing their fair share of probes into the Moon, either by design or by accident. Later on, certain missions used controlled crashes against the Moon for science. Such is the case with the spent S4B stages from the Saturn V rockets that sent people to the Moon. These crashes occurred with objects whose mass, size, and impact speed we knew beforehand. These crashes allowed scientists to gather information from the impacts using seismometers or optical observations and translate that into what a similarly sized asteroid would do. The seismometers also got a free moonquake, allowing scientists to study the Moon's interior. But those were intentional crashes for science. Unintentional crashes still happen. For the most part, whenever there's a moon-bound launch, the upper stage from that launch often stays on a similar moon-bound path, or at least in a highly elliptical orbit around the Earth that's close to the Moon's orbit. In these situations, it's not that hard for gravitational perturbations from the Moon, other planets in the solar system, and even solar activity to push the object in just the right direction to put it on a collision course with the Moon. Sometimes this happens and we're not even aware of it because these are small rocket stages left in faraway orbits, so it's not easy to track them all the time. So much so that in 2022, one of these rocket stages was rediscovered and initially thought to have been a spent Falcon 9 stage like the one from this week. This generated similar headlines that quickly disappeared because after many more observations, it turned out the object was actually a Chinese upper stage from a completely different mission. These unintended impacts can still be useful for science as long as we're aware of where and when they occur. For example, in the case of this week's impact, teams at the European Southern Observatory, using the creatively named Very Large Telescope in Chile, were able to capture spectral lines of sodium and lithium from the dust plume generated by the impact. While a lot of people were trying to capture footage of the impact in real time, it turned out to be more elusive than previously thought. As of the time of this recording, the only instance of someone capturing this came from the Andalusian Institute of Astrophysics in Spain, which was able to observe the dust ejected from the impact. After the fact, the South Korean Donuri spacecraft was then able to image the impact location, showing that a teeny tiny crater had been created on the lunar surface around the estimated impact site. With all this being said, with a moon base coming up, perhaps these crashes should not happen in the future. Or, at the very least, if there's no good alternative, maybe they should be controlled crashes, just like we already do here on Earth by deorbiting over oceans instead of populated areas. It's definitely a good problem to have. Speaking of the moon, next week we're going to have the next total solar eclipse. This total solar eclipse will be the first one visible over Europe in more than 2 decades, and the first over the Iberian Peninsula in more than a century. The path of totality will start around northeastern Russia and then pass near the North Pole, moving south over Greenland and the western side of Iceland. Much of the rest of the eclipse will then take place over the northeastern Atlantic Ocean before moving over the Iberian Peninsula and ending in the Balearic Islands. Here at NSF, we'll be covering the eclipse live on location from multiple sites, including one right in the middle of the path of totality in Spain. As a reminder, don't try to look directly at the sun while the partial eclipse is ongoing. Make sure to wear the correct eye protection and only remove it during the totality portion of the eclipse if you're lucky enough to be in the path. While the moon and the sun dance their cosmic ballet, next week is also going to be packed with more launches. SpaceX is up to 3 Starlink missions on the schedule, 2 from Vandenberg, 1 from Florida. From Japan, we'll have the launch of the Michibiki 7 satellite on an H3 rocket. The launch had been scheduled for this past week, but was postponed due to bad weather. And from China, we should have a launch out of Wenchang and another from Zhoushan. That last one could be the second flight of Landspace's Juche 3 reusable Methalox rocket, so it could feature another booster landing attempt. They got pretty close last time, and a booster landing would be a great follow-on to last month's catch of the Changzheng 10B. But for now, I've been Ryan Caton for NSF, thanks for watching, and goodbye.